This program is a presentation of UCTV for educational and non-commercial use only.
The same religion that's capable of hideous acts of destruction can also be capable of moments of healing, of restoration, and of hope.
But educate a girl, and you educate her entire family.
There is a sun within every person.
When that anger sets in, write it. Write the letters, but don't send them. You never want to leave concrete proof of insanity.
Tonight, I'm going to talk about design as a signal of human intention. And I'd like to talk about abundance and not the limits that we're so used to hearing about when we talk about the environment, but the abundance that's in the environment and in our goodwill and our creativity. It's something we live and something we dream. Now, to give you a sense of what I'm doing right now, I put here the companies that I work with. I work as an architect with William McDonough and Partners. I work with Michael Braungart and McDonough Braungart Design Chemistry, which now certifies against cradle-to-cradle protocols, which I'll talk to you about. And I'm a venture partner at Vantage Point Venture Partners, a venture capital firm in Silicon Valley, investing in clean tech investments. Now, when we look at design as the first signal of intention, we have to ask ourselves, what is our intention by design? When we wake up in the morning and have designs on the world, isn't design about making the world a better place? And if that's true, then the first question has to be, what is our intention as a species? Because it's not clear. If we look out in the world, what we see are climate change, global warming, persistent toxification, endocrine disruption, plastics in the oceans, heavy metal contamination, and on and on. And as we look at all of these conditions, we have to ask ourselves, did we intend for this to happen? And if we didn't intend for it to happen, then what do we intend to happen? Because if we say what is going on is not our plan, then what is our plan? Because what's going on is our de facto plan. It's the thing that's going to happen and continue to happen if we don't have another plan. Now, our species dominates the entire planet, so our designs can encompass the entire planet at this point in our history. Now, when we look at this idea of design and the natural world, we can go back to Thomas Jefferson. I've had the privilege of coming here from Charlottesville, Virginia, where I live, and had the privilege of living in a house designed by Thomas Jefferson. And when you live in a house designed by Jefferson, you think of him as your architect. And I think that Jefferson saw himself as a designer too, because all you have to do is look at his last design, which was his tombstone, and on it you'll notice that he only recorded the things he designed. It says, Thomas Jefferson, author of the Declaration of American Independence, the Statute of Virginia for Religious Freedom, which matured into the Bill of Rights, and father of the University of Virginia. That's it. Anything missing? Can you imagine being president of the United States twice, and it's not important enough to put on your tombstone? Here we realize that he's recording his legacies, not his activities. No mention of his jobs, simply the things that he designed and left behind for future generations. And this idea of recording our legacies free from remote tyrannies is fundamental to the Declaration of Independence, written when he was 33 and written in 16 days. And this idea that we would celebrate life, liberty, and the pursuit of happiness in the context of freedom from remote tyranny was not lost on Mr. Jefferson, clearly. And not only that, but the whole idea of intergenerational remote tyranny was not lost on him either. In 1789, he wrote a letter to Madison while they were designing the federal government. Goodness. Do you see what I just saw? Yikes. Okay, let's see if we can do this here. It just crashed and burned. What is going on? It's not plugged in. The power is not plugged in. Where's the power? There it is. Sorry, everybody. I don't know how that got unplugged. That's plugged in now. Okay. So how do I get it back? Just do that. Forgive me. There we are.
Turn it back on.
Should be good. Okay. I go with the technology. Okay. In 1789, Jefferson wrote a letter to Madison while they were trying to design the federal government and its ability to finance itself. And Jefferson thought the government should be able to borrow money on the term of 1 generation. And his logic was this. He said, the earth belongs to the living. The earth belongs to the living. No man may by natural right oblige the lands he owns or occupies to debts greater than those that may be paid during his own lifetime. Because if he could, then the world would belong to the dead and not to the living. The world would belong to the dead. Now this idea of humans having natural rights, I think if we looked at it today, and Mr. Jefferson were here with us, we'd be looking for declarations of interdependence, and we'd be looking at the rights of nature, as Roderick Nash has here at this university. And what we would look at is the history of rights going back to Magna Carta, the rights of noble males, then Mr. Jefferson's Declaration of Independence, the rights of white landowning Protestant males, 6% of the population. Then we'd see emancipation, suffrage, welcome aboard ladies, 1920s. Then we see the Civil Rights Acts of the 60s. And then in 1973, the first time something other than a human being is given the right to even exist with the Endangered Species Act. So this idea that we would think about our concept of rights extending to nature itself, I think is a signal of design intention. And it's a signal of design instruction. If we look down here in the lower left corner of this picture, you'll notice some killdeer eggs. This is a picture of a roof. This is the roof at the Ford Motor Company Rouge plant. And those birds arrive within 5 days of the roof being put down. The rights of nature itself to even exist, because otherwise a typical building would have left behind asphalt, which in our lexicon is obviously 2 words assigning blame. So what is the first question? The first question, as we just heard for us, is how do we love all the children of all species for all time? This becomes the principled question. And how would we do this by design? Well, we'd need to have a clear goal. And so I tried to get it all crammed into one sentence. Here it is. Our goal is a delightfully diverse, safe, healthy, and just world with clean air, water, soil, and power, economically, equitably, ecologically, and elegantly enjoyed, period. I had the privilege of presenting this twice in the Bush White House recently, and which for me, as you can well imagine, was an anthropological field trip. And when I got to Washington, I went into the meeting with all these senior executives of the federal government. I presented this, and at the end of it, I was asked, well, what do I think of clean nuclear power? Now, it's amazing how many environmentalists are focused on nuclear power now because of the carbon question. And that's a whole nother debate I think our culture has to deal with. But as an architect dealing with these small-scale questions of buildings and regional plans and molecules, I'm interested in nuclear power in a certain way. Specifically, I'm interested in nuclear fusion. I think we should spend trillions of dollars capturing the effects of nuclear fusion immediately. And I am delighted to know that our nuclear reactor is exactly where we need it, 93 million miles away, It's 8 minutes and it's wireless. What is our problem? So I love clean nuclear power. Now, we have been somewhere in a social market economy between capitalism and socialism over the last century. And what we recognize is that any ism is a dangerous thing: Nazism, fascism, sexism, racism, capitalism, socialism, and so on. Because isms are dangerous things because they're too close to the bone. And so when we look at a pure capitalist who cut down the trees and forget the fish, pure socialist would yield, as our scientists tell us, a former USSR that is now 16% uninhabitable. 16% uninhabitable. The equivalent in the United States would be having to put a fence around Texas. That's how scary this is. Now, so there's another ism that's been missing, which is ecologism. And when we look at ecology as the third corner of this triangle, what we realize is that ecologism itself would be a dangerous thing because it would forget the economy and forget society. And so we've ended up with this famous triad of sustainable development: ecology, equity, and economy. But what I'd like to do today and tonight is talk a little bit about why triple bottom line thinking, which has been used as a reference point for this triad, isn't going to be sufficient because it's triple bottom line. What we really need to focus on is to reverse this and put that aside for the moment and think about triple top line revenue generation, not bottom line profit extraction, but revenue generation, because you can't manage something to a profit if you don't have revenue. So I'd like to talk about economic revenue, social revenue, and ecological revenue. Then we can talk about the triple top line instead of the triple bottom line. So if we use this fractal triangle to help us examine this issue from a design perspective as a design tool, then in order to be 100% fabulous, you would want to be ecologically, equitably, and economically intelligent. So that would mean you would want to be economically intelligent, and that would mean in this lower corner here, what would it mean to be 100% down here? This is the economy corner of the economy corner. So the question here is, can I make it and sell it at a profit? And we tell our commercial clients, if the answer to that question is no, then don't do it, because you're out of business. Then this question is the equity corner of the economy triangle. What would that question be? Well, are people earning a living wage? For example, this is something that, large companies who work in Asia and so on, and in the United States have to worry about significantly, and do. Then we would go to the equity corner and go to the economy corner of equity. What would the question there be? Are men and women being paid the same for the same work, for example? Equity first. Then equity, nothing to do with ecology or economy. What would the question be? Are we treating each other with respect? This is where we would find racism, sexism, and things like that. Then the ecology corner of the equity corner. Here we might find, is it fair? Is it fair to put cancer into our products, which we seem to do with great regularity? This would be ecology equity. Is it fair to cause climate change or to burden future generations? Ecology, am I following nature's laws? And then here, what we call eco-effectiveness. Are we following nature's laws while being economical creatures? And then here, eco-efficiency, where am I being efficient with resources? And what we see is out there in the world that most people are dealing with this triangle still. Because what you'll find is people dealing with economy corner, they'll deal with things like this. This is business for social responsibility, and this is eco-efficiency. Can I be more efficient with the systems? But we had one client come to us and say they had saved $200 million by being more efficient with energy, more efficient with water, and using post-industrial waste in their product. And we said, you haven't done anything. It's not an environmental program you're describing. You're describing just bad management prior to doing this. You were throwing away $200 million worth of your potential revenue for for unknown reasons. It's just simply bad management. This isn't environmental protection. This is just business. Now, Peter Drucker pointed out in his book, The Effective Executive, that it's a manager's job to be efficient and to do something the right way. But it's an executive's job to be effective and do the right thing. So what we'd like to look at tonight is what does it mean to do the right thing by the natural world, and see what the impacts on society and on the economy would be. Well, I think the first thing we have to think about is what does it mean to become indigenous people, to become native to place? That becomes the first question. And what does it mean to be native to place? Well, I think in the 1960s, when we saw this image, the most published image in history, we see this change of consciousness, and we become citizens of planet Earth. But what does it mean to be indigenous to this place? I was talking to Randy Komisar earlier, and Randy said, why don't you tell the story about the Yakima in Washington State? And it's a wonderful story about what it means to be an indigenous person. The scientists and semiologists had been called together at the Hanford Nuclear Repository in Washington, where we store the plutonium for our bombs and missiles. And they were there to design a sign. This is a true story. They were there to design a sign to put on the ground where we store the plutonium so that even an extraterrestrial 5,000 years from now wouldn't dare to dig. Imagine that design assignment. And the Yakima heard about what the scientists were doing and started laughing and said, you know, you really don't need to worry about this. We'll tell them where it is. This is what it means to be an indigenous person. You're not leaving. So as soon as we start to realize we're not leaving the planet, we all become indigenous people. Warren Lyons, a faith keeper of the Onondaga, was asked by the UN to come to an indigenous peoples conference, and his response to the UN was, who's not indigenous? So we all are indigenous to the planet. Well, what does this tell us, and what do we know about what we're meant to do with that information and how we're meant to feel about it? And what are our designs going to look like if we're not leaving? Well, our tools and our science can tell us amazing things. For example, here in the Pacific Gyre, right off the coast of Santa Barbara, a few years back, 6 times as much plastic was found versus plankton by weight. 6 times more plastic than plankton. Waste from the west coast of the United States. Recently, the test was redone, and it's 46 times as much plastic as plankton. What else do we know? 48% of the anthropogenic carbon dioxide produced by humans since the 1850s is in the oceans. And historically, it's been at 8.8 to 8.2 pH. It's now at 8.06, and there's expectation that it could drop to 7.9 by end of century. At 7.9 pH, we apparently lose the bottom of the food chain. Coral reefs dissolve. Crustaceans can't form shells, things like that. So if this is our plan, if our plan is to acidify the oceans, to fill them with plastic, to cause climate change, et cetera, then we are doing great. But if that's not the plan, what's the plan? So we look at the natural world for inspiration and try and figure out what the laws might be. Here's one right here. This is one I have to pay attention to in architecture. This is known as gravity. It's not just a good idea, it's the law. Well, what other laws might there be in this picture? And so we've been thinking about these, and I wrote the Hanover Principles with Michael Braungart in 1991, designed for sustainability. It was given by the German government to the Earth Summit as a gift, designed for sustainability. And then in 2002, we came out with Cradle to Cradle, which is a plastic book. Now, why would we do a book out of plastic? Well, it's described in the first chapter. First of all, we're awash in plastic, obviously. But it also describes in the book why this book is plastic in terms of it being not a tree. Because at this point in our history, we have to think about elegance in design and humility by design. And if anybody here has trouble with the idea of design humility, just remember it took us 5,000 years to put wheels on our luggage. We're not that smart. So, if I gave you a design assignment for a tree, what would I be asking you to do? Think of it, about it. I'd be asking you to design something that makes oxygen, sequesters carbon, can fix nitrogen, distill water, provide habitat for hundreds of species, accrue solar energy as fuel, make complex sugars and food, change colors with the seasons, create microclimates, and self-replicate. How are we doing? How many things do you know that humans made that made oxygen lately? So why would we use something as precious as that to do something as prosaic as a flat white sheet we write on? And so we wanted to explore the idea of what we call technical nutrition with the first book. The next book that's coming out will be different. And one of the things we say in Cradle to Cradle is that being less bad is not being good. It's being bad, just less so. So all of the people who talk about minimizing their badness are talking about minimizing their badness. So what we're looking at is what would it mean to be more good instead of going out there just to be less bad? Wouldn't that be more exciting in a celebration of abundance? And that abundance would be like that of a cherry tree in the spring, where we celebrate its abundance. We don't look at a cherry tree and bemoan its inefficiency. I don't hear anybody saying, oh my God, look at that tree, how many blossoms does it take? We celebrate this abundance, and we want this abundance. I mean, think of listening to Mozart. We don't listen to Mozart and think, how many notes does it take? He could have hit the piano with a 2x4 and got them all at once. We love the celebration of abundance. We want this creativity, but we want it to be safe and healthy. So we look at these blossoms, they return to the soil, they return to the trees. This goes on over and over again in cycles, and it's a celebration of growth. And growth, in this context, is good. So instead of environmentalists sitting here wringing their hands talking about growth being bad, we could talk about growth being good if we follow the laws that nature puts in front of us. So, not being a scientist, I immediately am pulled to using science for poetic purposes. And I like to look at the two discoveries of the last century that inspire me as a designer, the special theory of relativity and the discovery of DNA for design inspiration. Now, when I went to college, I remember asking my physics teacher why Hiroshima disappeared and why Einstein was afraid. And he said, oh, that's relatively simple. If you look at this, C is a very big number. So you square it, it's almost infinite, which means that if m is in any way a positive, then E is almost infinite. This is why a little bit of m can yield a huge amount of E. This is why Hiroshima disappeared and Einstein's afraid. Conversely, if you'd need a huge amount of E to create any part of m, and so what that tells us by design, as a design poem, as a little koan to work on, is that physics is really energy in the sun. And we have this beautiful nuclear fusion reactor 93 million miles away, making kinetic energy turned into photons. They get here in 8 minutes. We have about 5,000 to 10,000 times more than we need to power human systems. And so we will solve the energy problem. We have a form of income. This is really important, income. When we talk about fecundity and triple top line, we have energy income. Now, chemistry and mass, the M on the equation, we don't have any mass income, occasional meteorite. That's about it. So if we take all the chromium out of South Africa and put it into little holes in the ground around the planet in our products that we throw away or incinerate, future generations will look back and say, what were you thinking? You took all the chromium and used it to toxify us and removed it from our utility. So we have to be really careful with the M because we don't have mass income. Now what happens when physics and chemistry get together? We get biology, something that Einstein called magic. And we can now look at Francis Crick 9 years after having discovered DNA with James Watson. He looked for what he called the nature of vitalism, what it means for something to be a living thing. And so what I'm wondering is, wouldn't it be great if human artifice could follow the same rules that Crick discovered when looking for what it meant to be a living thing? And so we would have growth. We would need growth in order for something to be alive, because things are dying, things have to be replaced. Just to maintain stasis, you have to have growth. You need a free form of energy from outside the system in order to have growth. And that energy comes typically from sunlight. And the third is you have to have an open metabolism of chemicals operating for the benefit of the organism and its reproduction. So I'd like to focus on that metabolism for a minute. Michael Braungart and I have sort of parsed this into two metabolisms: the biological metabolism and the technical metabolism. This is the human artifice as a living thing. And so for living things, we see designing things like fabrics and certainly textiles, things of wood, various materials that are designed to go back to biological systems and the biological metabolism. They should all be designed to be safe, not just that they biodegrade, but they biodegrade safely and they don't have persistent toxins or bioaccumulative substances, things like that contaminate mother's milk. And then the other would be the technical metabolism, things that go back into that technical cycles, what we would call technical nutrients. So we have what we call biological nutrients, designed to go back to biology and rebuild our soils, which need desperate rebuilding. And technical nutrients, things that are designed to go back to industry, what we call products of service. What we really want is the service of the thing. We don't need the ownership of the molecules. And so we can really think of this as almost like a leasing concept. We want the service of this computer for a certain amount of time, at which point, we want a new one. And wouldn't it be wonderful if the old molecules could go back to be reformatted into new molecules without being released into the biosphere in hazardous ways and things like that. So we call these products of service. Things like carpet, which is where we started, where we talked to the carpet industry about essentially leasing their carpets in all effects and purposes, so that when you finish with a carpet, you call them up and they want it back. It has a 1-800 number on the back. It says 1-800, it's ours. You come and get it, take it back, and then recycle it. The problem we have with a lot of the carpets today is they're made with PVC. And so they were never designed to be recycled, so we're recycling toxins. That's why we work with companies to redesign their products and retool under the new protocols. So what is eco-effective design in this context? Well, it would have design principles. Waste equals food. Use current solar income and celebrate diversity. Those become the design principles. And then the question is no longer growth or no growth, but what do we want to grow? And we get to choose what we want to grow for the future. Prosperity, health, security, community, peace, culture, and so on. So how would we do this? What would our target be? How was our trajectory developed? Working with the U.S. military, where we were looking at a program for how to design 100% renewably powered components, we started to look at this idea of creating a flight path for them, where we look at what it means to be 100% renewably powered, for example, in their case. So you could use this, we use this with corporations on their diversity desires or things like that. It's a very useful chart. It's very simple. We developed it with PricewaterhouseCoopers. So it's basically we set out 100% sustainable strategy. We do that by coming together to determine it, and then we set up a flight path to get there. And what we discover is that eco-efficiency is incredibly valuable in the short term because it can reduce your demand dramatically, and so it's critically important. But it's insufficient to the task because you can reduce your badness by as much as you want, but you still have that component. And so what we really need is this invention and creativity that humans can bring to this story now, which we call eco-effective design, which looks at the 100% good. And the spread between efficient and effective is leadership. It's the difference between a manager and an executive. So let me just show you some projects and where I come from, and then we can do questions. I was born in Tokyo in 1951, and as a baby, I remember lying on a futon at 2.5, listening to the ox carts come in to Tokyo from the farms to take away our sewage. And my mother, in her sing-song Alabama voice, would call it the honey wagons were coming to collect the night soil. And when you're 2.5, stories about poop are really interesting. So we thought this was great, that our waste went out and came back as food. So that's something that's been sort of blazoned across my consciousness from childhood. Then we moved to Hong Kong, where we live with 6 million people on 40 square miles. And we had cholera, typhoid, typhus, people dying of starvation, sicknesses of all kinds. And everyone was really careful with everything because the limits were tremendous. And during the dry season, we had 4 hours of water every 4th day trickling out of the faucets. And that was it. And the relationship of the people to the land was fundamentally different than it is here. This land has been continuously farmed for 5,000 years. Now, how do you farm the same piece of dirt for 50 centuries without understanding nutrient flow? In ancient China, it was impolite to leave someone's house in the country without leaving a deposit after a meal because you were taking their nutrition. It's a very tight equation. I spent my childhood summers in the Puget Sound of Washington State, where my grandparents lived in a world of abundance. Big trees, salmon, oysters, compost, flowers, fruit, huckleberries, and yet they were very careful with everything. And then as a teenager, my dad became the president of Seagram, overseas the international wines and spirits business. And we moved to New York, and I lived in Connecticut. And I saw the kids leaving the showers running after gym. And I couldn't believe it. I went into shock, and I still haven't come out. So I started my practice by building a solar-heated house in Ireland when I was at Yale in graduate school, which, to give you a signal of my ambition, because there is no sun in Ireland. But then in 1984, I was hired by Environmental Defense Fund to design their national headquarters. And the head of EDF, who was an attorney, said, if anybody gets sick from indoor air quality in our office, we're going to sue you. And so we went to our lawyers and said, what does this mean? And he said, it's called negligence. Negligence is knowing better and doing it anyway. We said, well, that's no problem. We don't know anything. What else? Well, negligence is defined by measuring you against your peers. What should you have known? And I said, okay, what should a 33-year-old architect in New York know? Well, apparently no one else knew anything either. The only consultants that we could find in the United States that could consult with us on indoor air quality at that time in the commercial office space were fundamentally financed by the R.J. Reynolds Tobacco Company, and their primary scientific mission was to prove there was no danger from secondhand smoke in the workplace. That was the state of the art at the time. So we started asking manufacturers what were in their products. Did they off-gas? Could they be recycled? What was in the paint? Was the light color good for human health, et cetera, et cetera? And the first answers we typically get were, it's proprietary, it's legal, go away. Well, we now work with companies whose annual revenues exceed $1.5 trillion, and we ask the same questions. And as we keep moving, we realize that our work gets picked up in different venues and thought about differently. Here in 2000, Business Week did a cover on our work and others called, Is Your Office Killing You? The Dangers of Sick Buildings. It's killing, danger, sick. What we're looking at is not getting people afraid. What we're looking at is trying to make change so these designs can change. Because how do humans deal with things that scare them? Here in California, you regulate. This is a Prop 65 warning from a building. Imagine this. You know, we have these concerns, and what we end up with is a label on a building. The state of California requires that we warn you that the property contains chemicals known to the state of California to cause cancer and birth defects or other reproductive harm. These chemicals may be contained in emissions and fumes from building materials, products, and materials to maintain the property, et cetera, et cetera, et cetera. What an amazing thing. So instead of changing the design of all of these things that cause these concerns, what we do is we warn everybody. So currently, what we do with materials, for example, is we just put out restricted substances. Well, wouldn't it be great if by design we took a full inventory of everything we're making? All 104,000 chemicals used by humans in manufacturing, 104,000, of which only 30% have been assessed for human and ecological health. And then if we took and did an optimization, instead of minimization of badness, we did an optimization of goodness and developed a protocol for that. So that's what Michael Braungart and I have done with Cradle to Cradle at MBDC. The first thing we do is an inventory. This is textile seatings, where we started for Steelcase Corporation. And then we have supply chain tools using the web to communicate up and down the supply chain with our concerns. We do assessments. Our assessments are based on scientific criteria. The priority criteria are no more cancer, no more disruption of our endocrine systems, no more genetic mutations, reproductive toxicities, or birth defects. Thank you. We worry about toxicities, we worry about irritations, sensitizations. For environmental health, we want no more toxicities for vertebrates, invertebrates, and for plants. We want to know about bioaccumulation, persistence, can things biodegrade, do they have halogenated organic compounds, toxic heavy metals, so on. And then for production and process, we want to know exactly what things are made out of, where they come from, where they go, what kinds of criteria are used in their manufacture. You'll notice that climate relevance and ozone depletion is the last one. And you know, the whole world is worrying about this one, and it's something to worry about, clearly. But you'll notice that it's only one of many criteria that go into cradle-to-cradle thinking. So we now have databases of thousands of chemicals based on these 19 fundamental criteria. And so we can search very quickly for endocrine disruptors, carcinogens, and so on and so forth, and help our client companies redesign all their products based on a red stop, green go system. An example was the textile industry. We looked at the organic textile industry and found that there are 8,000 chemicals being used. When we assessed them, we determined we had to eliminate 7,962. We were left with 38 chemicals to do the entire fabric collection, which we did. And now the fabric is so clean you can eat it. It's been selected by the Airbus 380 as the fabric of choice, which is really great news for frequent flyers, because if you find yourself at 40,000 feet with a fiber deficiency, you could eat your chair. We then do optimizations, and based on the cradle-to-cradle design framework. So everything we start with is determined in terms of how it can be seen as a nutrient. We design the products to be recycled, and we design the systems that are used to recover and recycle the nutrients. We then certify against this performance with 5 criteria. Are you making a biological or technical nutrient? Are you reutilizing materials? Is your energy coming from renewable sources? Is your water clean enough to drink? And are you practicing social responsibility? And then you get into the system with basic certification. You're checked again every year, and you work your way up to platinum, which is a perfect cradle-to-cradle product. During the optimization, we go from red to green. And let me just show you some of the products that we've done as an illustration. For biological nutrient, this is the textile that will be in the Airbus. And when we first got there, the trimmings of the bolts of cloth in Switzerland had been declared hazardous waste. They couldn't be buried or burned in Switzerland. They had to be shipped to Spain. And you realize that when your trimming is declared hazardous material, but you can sell what's in the middle, you've reached the denouement of the first industrial revolution. You're obviously making hazardous waste. So at the end of our work with our chemicals redesign, the trimmings are now mulched for the local garden club, and the cycles can start to close again. Thank you. In the world of technical nutrients, working with Warren Buffett and Shaw Industries, Berkshire Hathaway, we developed a carpet collection that's made from nylon 6 face fiber, which can be taken back easily through chemical recycling to caprolactam to be recycled as face fiber for carpet. And the backing is a thermoplastic polyolefin that can be separated easily using gravity separation and returned with heat to the base. This compared to all the other companies which are making PVC backing that is then turned into a mush with the nylons and made into backing with a nylon hybrid. It's what we call a monstrous hybrid, and recycling the PVC, which is a precursor to dioxins, as I'm sure you're aware. So what Shaw did was retool and actually design based on the cradle-to-cradle model so that not only could they effectively lease their carpet and take it back when you finish, but they designed it to be truly recyclable. We've done the same thing now with Steelcase, Herman Miller, Hayworth. The major furniture companies have cradle-to-cradle certified chairs. They're designed for disassembly. They come apart in a few minutes with tools that you'd find in a kitchen drawer. And I just took one apart the other day and put it back together 4 or 5 times for a film we were making, so I can vouch for this personally. Meco Shade has gotten away from PVC and gone over to polyolefins. The U.S. Postal Service now has cradle-to-cradle certified priority mail envelopes and boxes. All the inks and glues and papers have been assessed for ecological and human health. Method, the company in San Francisco making cleaning products, is a cradle-to-cradle company certifying against cradle-to-cradle for its products. This is a new product that's just coming out of Santa Barbara, which is a non-tree-based packaging. Oops, having trouble here. Sorry. For Nestle Waters and for Whole Foods and Waste Management Inc., we worked on a project to get a new bottle for water that is 25% recycled content on its way to 100 with the reverse logistics. So we're actually developing the reverse logistics system, and they're being put in the Whole Foods now for testing so that all the bottles can be taken back and become clean polyester, actually getting upcycled instead of recycled or downcycled, actually getting better as it goes through the recycling systems. And working with the state of California and the Green Chemistry Initiative, California has decided to move toward a cradle-to-cradle economy. This was signed by the governor in last spring, to leverage market forces and produce products that are benign by design, by creating registries and sustainability indices and so on and so forth. We're very proud of this and very excited for California, and stand by to work with them in the creation of this. Now, because I'm an architect, I have to show you some buildings, and then we'll take some questions. I like to think of buildings like trees and cities like forests. So we're looking at what would it mean if a building could be cradle to cradle and follow the same protocols as the products. And so imagine a cradle to cradle building and all of its parts. So we think about design for disassembly even for buildings. And in buildings, they have a much longer life than simple products. So we start with material production, go through the building production, think about occupancy and use, go back to material recovery over different periods of time. And different parts of the building have different life cycles and recovery times. Stuff, we call it, inside the building might get replaced 8 times in 7 generations. Systems might be replaced 4 times. Setting might be replaced 3 times. The skin might be replaced twice, the structure once, and the site is eternal. So we look at that and start to imagine all of these things from stuff to site and how it might all come together in a building. This is a building we did for the Bernheim Forest in Louisville, Kentucky, which is designed out of woods from the forest itself and designed to be solar powered, absorb water, and return to the forest when we're finished with it. This is a building for Oberlin College. We did for David Orr, Professor David Orr, working with Rocky Mountain Institute and with John Todd, who did the waste management system, the wastewater system. And so the building itself makes 13% more energy than it needs to operate. And so it's a net energy exporter. And it purifies its own water, a building like a tree. For the Gap in San Bruno, California, now YouTube's headquarters, an office building where we put a meadow of ancient grasses on the roof to absorb stormwater and dull the sound of airplanes flying overhead from San Francisco Airport and provide habitat for native species. The building's designed to be converted to housing in the future. So if it ever finishes its purpose as an office building, it can become an apartment building. This is a picture of the roof. This is for Herman Miller, a factory where they make the famous Aeron chair. We designed the factory, and the chair is now cradle to cradle. They're restoring the native landscape, and the workers all celebrate the same public space as the office workers and the factory workers that share this common street full of street life inside the factory. It was built for $49 a square foot, which is equivalent to 10% more than a Butler building, 1993. The building is full of fresh air and daylight. The workers wear aloha shirts and play the Beach Boys and think they're in California. And performance doubled. They went from making $250 million worth of furniture to $350 million worth of furniture. Same people, different building. This for Mayor Daley. We did the green roof in Chicago for City Hall. He wanted to explore the idea of why couldn't roofs in Chicago be green, and now he's got a tremendous green roof initiative, one of the models for the planet. For Nike in Europe, we did their corporate headquarters. It's all geothermally powered, no PVC, designed to be converted to housing in the future using local materials. For Ford at the River Rouge, we had a project to revitalize the River Rouge, Henry Ford's sort of center of mass production. This is the existing kind of facility that was there. Talk about asphalt. And so we decided to use these tools instead of chemical engineering, use the native species and native systems, and got permission from the federal government to clean the soils using plants instead of digging it up and burying it and burning it. And we built the world's largest green roof. This is 10.5 acres of habitat. Everything on this roof is daylighting except for these 4 air conditioning units. We developed a new way of air conditioning and heating and cooling a large building where we just deliver a bubble of air to the ceiling using these wind tunnels, and then the air just sinks and then pokes out of the building out of these little holes. Every 3 seconds the louvers open and close to determine where the air should move to make the people comfortable and give them fresh air. The way we got this through the Ford board was very simple. I had 1.5 minutes to present the project for approval. So as I was walking in, Bill Ford said, well, Bill, I'm sure they didn't give you a lot of time, take twice as long as they gave you. So I figured, okay, I have 3 minutes to do this. But we walked in and said, we've looked at your conventional stormwater management system, it's $48 million. And with the green engineering, it's $13 million. And this will save you $35 million the first day. And with the Ford Taurus at a 4% margin out of Chicago, that's the equivalent of an order for $900 million worth of cars. So it was approved in 1.5 minutes. And then we got to build this. So this is the roof. It's only 1.5 inches thick with sedum growing on it. And it changes colors with the seasons and provides habitat for other species. This is a building for the National Museum of Science and Industry in the UK, as the Museum of the First Industrial Revolution. The building is solar powered, 6 football fields large. Our proposal includes putting sheep on the roof, because everybody makes jokes about our buildings that we have sheep on the roof, so I figured, well, let's have a building with sheep on the roof. Sounds like fun, actually. This is an experimental airport, solar powered. Turns out the electric cars would be the storage for the solar power that would be generated by the building. This is a project we're doing for NASA called Sustainability Base here in California at the Ames facility, a building that is designed to not require external inputs of energy, using locally resourced ground source and solar collection, natural ventilation, things like that. You can see the amount of energy, the amount of water that it uses. This is a conceptual project for NorCal in San Francisco, which is trying to be which is the waste handler of San Francisco, looking to become a zero waste nutrient management company instead of a waste company. This is a study for a 10 million square foot distribution center in England for products that would come in, go out to the marketplace and come back from the marketplace to be recycled. And it would be invisible, hidden by berms, and silent and invisible and solar powered and water purifying. I threw this in just to sort of show what some of these things could start to look like. This is an installation of solar collectors in Bavaria, and I can easily imagine that these would be a building and could be the kinds of things that we use for distribution of goods and services while they produce power. This is Bright Source Energy. As a venture partner at Vantage Point, we've invested in Bright Source, which is the thermal electric production where the towers are receptors for the mirrors, and then steam turbines are run from the hot liquids. And we're also a venture capitalist in the Better Place project for Israel and Denmark now, where an entrepreneur named Shai Agassi has put forward a proposal to work with Renault Nissan and develop electric cars that would have battery stations, battery exchange stations that have just been tested in Japan, and they've been shown to be really tremendously effective. And the idea is to get Israel off of oil. And then we'll see it happening in Denmark too. And then finally, I'll show you a few quick projects. One I'm doing with Brad Pitt in New Orleans. We decided to help out in the lower Ninth Ward after we could see that nothing had happened where the levee broke after 2.5 years. So we decided to build 150 houses and help people come back to their sites. And so as a fundraising effort in honor to Christo, we put up 150 cradle-to-cradle tents in pink. It was Brad's idea. To symbolize the assignment at hand and allow people to help understand the scope of the problem. And we've raised the money to go ahead and help the people living in the lower Ninth Ward to come back to their homes. But we did it by hiring 13 different architects who are all ascribing to the cradle-to-cradle philosophy to design houses that we could either build with modular or stick or panelized construction and get people back into their homes, solar powered. The energy bill on one of these houses, we found out from the owner, was $20 a month. So they can afford to come home. This was built by Graft Architects from Berlin, Kieran Timberlake from Philadelphia. And we're looking at a 7-generation transformation into cradle-to-cradle products over time as we can get more and more products certified. Our firm is designing a house now for the next round that will be 100% cradle-to-cradle. And finally, 2 large projects. This one in Amsterdam, near Amsterdam, which is here, for the city of Almere, which is doubling in size. We work with them to develop principles, because what we've found is that people start with metrics and then they move up to tactics and then strategies and then goals and never remember the principles of what they're doing. So we like to start with principles, go to goals, strategies, tactics, and then metrics. And so these are the principles developed by the people for the development of their city. There's a whole book that goes with it. And then finally, I'll show you a project we're doing in China. Why China? Well, China will house hundreds of millions of people in the next 10 years. And we were asked by the city of Luzhou in the south of China to develop their horizontal master plan, the ground plan for their future development on this site adjacent to the city, which suffers from flooding and things like that. This is the site. And after developing the horizontal master plan, which they're proceeding with, we decided to have some fun with it and start to imagine what it would be like to have a waste equals food city. So we started imagining what if the waste from humans went to fertilizer factories that made struvite, an amalgam of phosphorus and magnesium and ammonia, crystalline form, which produces fertilizer, slow-release fertilizer that's clean. And that could be used to grow food and restore the city's biodiversity. By, instead of sugarcane monoculture, it would have parks and gardens and so on, and purify water and grow bamboo for the doors and floors of the city. To provide the cooking gas. It turns out to be about 21% of the city's cooking gas could be provided by the waste treatment systems. Then we looked at how much solar energy would be generated by the city itself or its bioregion to be used to power the city. But I think the thing that got the most attention was when we proposed that the city lift the soil up onto the roofs of the city. This came from a statement from the Premier of China, who had said that China would lose 20% of its farmland by 2020 if it continued its current urbanization at current rates, 20% of its farmland. So we thought, wouldn't it be wonderful if we could have Paris with farms on the roofs? And since we can draw things anytime we want to, we just went ahead and drew it up. So there it is. And when everybody in my office was thinking I'd really lost it, somebody in China sent us this picture. This is rice growing on a terrace in southern China. So the question is, what is our intention as a species? Our goal is a delightfully diverse, safe, healthy, and just world with clean air, water, soil, and power, economically, equitably, ecologically, and elegantly enjoyed. And our question is, how do we love all the children of all species for all time? Thank you very much.
What is the proper relationship between eco-efficiency and eco-effectiveness? Does effectiveness include efficiency or not? Second question is, how often do you confront scientific uncertainty with respect to the human health effects of the chemicals that you catalog? So what do you do when you simply do not know the effect on the human body or the ecosystem for one of those chemicals that you catalog and manage that in the cradle-to-cradle process?
Great, two great questions. The first question is absolutely efficiency is incorporated with effectiveness. They go together. There's no question that you could look at efficiency as demand-side management and effectiveness in many cases as supply-side management, and so they go hand in hand. It would be foolish to, for example, try and solar power a building that was inefficient because you're dealing with some obvious economic unreality if you try. So they definitely go hand in hand. We're not against efficiency at all. We're for it. We see it in conjunction with effectiveness. But we think that, when you think about efficiency per se has no value on its own from a philosophical perspective because it's like any other tool. It depends on what you're doing efficiently. See, an efficient Nazi is worse than an inefficient Nazi. So is efficiency a good? Right? It has no value. It's like a hammer. A hammer doesn't know if it's good or bad. If you hit somebody in the face with it, it's bad. It's a weapon. If you build a house with it, it might be a good. So a tool only has value for the purpose to which it's been put. So efficiency only has value for the purpose to which it's been put. So that I think is the fundamental difference. So absolutely efficiency and effectiveness go hand in hand. Your second question I think is really important. What we're trying to do with Cradle to Cradle as best we can, and it's a very humble undertaking, as you can imagine. It's humbling because with 104,000 chemicals and all the uncertainties, it's quite a dramatic exercise. But what we find is that there are certain things that are just undefined. They've never been tested. We don't know their effects. We don't know their synergistic effects with other chemicals, things like that. And so a lot of things are undefined as we move forward. And what we try to do is limit the number of undefined things so that as we're working on the redesign of products, if we find something that we don't really understand, we use the precautionary principle and try and avoid it until we understand it better. In the meantime, use something else. So there's a whole gray zone out there that we just have to characterize as undefined.
When we look out into nature, we see a very, to me, we see a very fundamental structure, very specific structure in terms of geometry, whether it's molecularly, you're talking about trees, flowers, a fractal geometry. I was wondering if you could talk about the importance of emulating nature's fundamental structure in design.
In a formal sense, I think, a lot of people find great comfort in natural structures. I think we find beauty in symmetry. I think we find beauty in natural curvatures. I think we find beauty in forms that have been created by gravity or by natural forces reacting against other natural forces and things like that. So I think there's a whole realm of possibilities that are coming with new materials and new systems there. And I think we'll start to see that relatively soon. In the meantime, I think that there's a whole move afoot to celebrate the local, and it isn't just local food or local production, but I think it's local form as well. I think over time we'll start to see a return of the indigenous forms to our architecture.
I have a two-part question. First, you speak about the role of government, the appropriate role of government, and I believe you mentioned that government and business is different, and business is more honest. So I would like to know the proper role of government in eco-effectiveness, and also how you decouple government from big business at this point, because I see the relationship actually being something that's going to defeat and work against sustainability in the future. If a business can make a lot of profit doing something and also gets protected by the government in doing that, then we have a very hard road to hoe here in terms of breaking that link to just a real strong motivation.
Yeah, great questions. One of the most inspiring people who thought about this for me, was Jane Jacobs. And she wrote a book called Systems of Survival. And in it, she talked about the fact that humans have evolved two syndromes, she calls them, the guardian and commerce. And the guardian being the state or government, and commerce being business. And she points out that if you get the two together and mix them up, you get what she calls a monstrous hybrid, which is what you're referring to in the second part of your sentence, this monstrous hybrid potential. And that it's really critical that we avoid the monstrous hybrids. And the example, an example of that would be that the guardian is meant to be really slow and serious and look out for the public benefit and public weal. It reserves the right to kill. It goes to war when threatened. And it's meant to shun commerce because that would corrupt it. Commerce, on the other hand, is really quick, it's highly efficient, it's very effective, it's highly creative, and it's fundamentally meant to be honest, because you can't do business with somebody very long unless you're honest with them. And she points out when the two get together, like the mafia, right? It does business but reserves the right to kill. That's a problem, So if we get, I think what we're seeing now, though, which I'm really excited about, is that even large businesses are looking at the sustainability question without being forced to do it by government. I mean, when you look at the whole LEED program with the U.S. Green Building Council, that was never started by government or forced by government. It happened because a lot of designers got together with the building industry and decided they needed some kind of benchmarking standard and went about performing on it. I think we'll see a lot of companies today looking at sustainability not because they're being forced to do it by the government, but simply that it's the right thing to do. And some of the actors will be surprising. I think we'll all be surprised. I'm hoping we'll all be surprised by Walmart and its exercises. I think they'll be surprised as anyone in terms of what it tells them. And I wouldn't be surprised if it didn't tell them that the optimized systems over time will become local again. I think that might be one of the lessons that will be learned in the process. but I don't know that it'll be mandated by any government activity. The role for government is to benchmark, I think. One of the things that frustrates us, for example, is like when we did that textile example and we found all those chemicals that were safe and did this fabric, our immediate thought was like, why wouldn't a government that, if it regulates their textile industry, say to other textile manufacturers, look what happened here in Switzerland, you could do this too. And I think that's the role of government, is to benchmark best practices and then offer those to their constituents as the performance. And if it has to be through a regulation, then so be it. But typically, in our book, a regulation is a signal of design failure. When you see a regulation, what you're seeing is the state, rightfully, and probably necessarily, stepping in to tell commercial actors that there's something wrong with what they're doing and that the public needs to be protected. So it's a signal of design failure. It means that the design is bad. And so we look at that and say, oh, there's a regulation, therefore there's more for us to do. Let us help redesign that system so the regulation becomes moot. But that, I think, is the biggest role for government, is to identify the best practices and share them with their people.
Applying your design principles to vehicles, cars, buses, what do we come up with?
When we talk about in the book, we call it the 5-year car. Essentially, there's this crazy perfect storm right now where we're looking at the cars as cars, and we're also looking at the people who make the cars and realizing that the entire system is collapsed. And what we need are jobs. And the auto industry has obviously been one of those places where they provide a lot of jobs throughout the whole system. And we're going to need jobs across the whole spectrum of human activity. But if we just focus for 2 minutes on the car, we see a car being something that really wants to last about 5 or 6 years and then get recycled into a new car. And so that on one hand, it's almost a celebration of change, because by changing the cars out quickly, we can upgrade them to electric cars with safe materials faster. So in a strange way, we don't necessarily want to see cars that last 30 years, because that means that we'll make a bunch of cars and then we'll run out of jobs. And we'll end up with the wrong car for 25 years. Because the technology is going to happen so fast. So I think as the technologies of sustainability mature in quicker cycles, that we're going to want to celebrate, this is, I know, going to sound really strange, but we're going to want to celebrate consumption and profligacy in a very strange way, which is that we could celebrate consumption of products that are designed to be consumed. But cars are never designed to be consumed. They should be designed as technical nutrients. And we should plan their obsolescence, but in the right way, not planned obsolescence as in make everybody want to get a new thing so that we can just churn the business, but make everybody want to get a new thing because we can create jobs and we can upgrade the technology to clean technologies that much faster if we do it. So for us, the car is we built an example of it with Ford called the Model U as a concept car, a cradle-to-cradle car. So the idea is basically recyclable cars that are cycled quickly to provide jobs and to upgrade the technology as quickly as we can to get away from fossil fuels.
You have been advocating for these issues for 20 years. How much progress have you seen in that time? And what can we do to increase the rate of progress towards sustainability?
Has it been 20 years? Seems like only yesterday. I think we've seen immense progress. When we looked in the last 75 days, there have been major announcements by some of the Fortune 500 companies relative to sustainability, big announcements. And even in these times, we're seeing these kinds of announcements coming out. So I think the ship has left port, and we're underway pretty fully. What was the second part of the question? Sorry.
What can we do to increase the rate of progress
What can we do to increase the rate of progress? I think just making examples. I mean, the fact is, if it exists, it's possible. And so that means that people can be inspired by it. And so I think the way it can happen more quickly is for us to get more and more examples into the marketplace that are celebrated as business successes. I think that's going to be a key element to this. It's not just a feel-good exercise. It's got to nail that economic corner for it to take off and become ubiquitous. So cost-effective solutions that are better than existing technology are what we're going to be looking for.
The longest continually inhabited building in North America is the Taos Pueblo in New Mexico. People have been living there nonstop for about 1,000 years. A building made out of clay, straw, sand. A building that in most places in the United States wouldn't be legal to build today because of regulatory authority. I'm wondering if you could speak a bit about projects that you've done or work that you've encountered where you've been able to work with regulations that don't make sense when there's solutions that have been evident for a very long time.
Yeah, it's good. Some examples. We, in 1977, I helped get composting toilets made legal in Pennsylvania because it just seemed natural that would be an appropriate thing to do. I think the way we deal with the regulatory space we typically encounter situations where there's no code for what we want to do because no one's done it before. So when we did the gap roof in San Bruno, California, there weren't big green roofs that absorb water in San Bruno. So the local building authorities were all scratching their heads. The fire departments were all scratching their heads. Everybody was trying to figure out what to make of this thing. And so we had to negotiate with everybody. And the negotiation was very productive because the city of San Bruno's stormwater systems had backed up. And so the building was realized as a benefit to the stormwater management of the city. That helped us get through that hurdle. The fire department, they decided that if we had an irrigation system to set the roof, that could be used as a sprinkler system in the event of fire. So they were willing to accept that. And they also agreed that we would weed whack the roof on July the 3rd so that if there were kids with bottle rockets or something like that, the roof wouldn't get be set afire. So you negotiate. We did raise floors through that entire building, computer floors, so that we could take the nighttime air of San Bruno, which is cool, and use it to cool the slabs of the building for free all night long, and then bring 100% fresh air to everybody during the day in their breathing zone under their own control. No one had ever done that before. There was no code for it. So we had to work with the code officials to write a code that would allow that to occur, things like that. So there is a lot of communication that goes on, and a lot of these things that seem simple and wise are not that easy to explain sometimes. But we've pretty much felt that we've been able to get what we want done if you take an open, generous attitude and communicate a lot.
I'm opening up an organic fast food restaurant. How can I make my restaurant a cradle-to-cradle restaurant?
That's fun. I hadn't really thought about a cradle-to-cradle restaurant yet. You would, well, you got to read the book first. But you'd want to look at everything in the. I would look at the whole restaurant as nutrition. It would be very appropriate. Just think of everything as a nutrient, everything, no matter what. So you ask yourself the question: is this napkin a nutrient? Right? If it is, then it's a nutrient for what? So if it's, it's unlikely it's polyester, it's probably going to be cotton or something like that, or it's probably going to be paper. I don't know what level of restaurant you're dealing with, but think of it as you do it as a nutrient, so that it's going either back to soil safely to rebuild soils, or going back to industry to be clean. And think about those two things as you move forward: biological and technical nutrients. And then That would help you understand whether you're going to use, if you use disposables, they would want to be compostable probably, most likely, depending on the kind of restaurant you're doing. The food would want to be as local as possible, organic. The people who serve the other people want to be really nice and friendly. I think that's important. And they want to be good storytellers so that they can tell the story of your restaurant to the people who come to it. But think nutrients. Everything is nutrition, everything, including the food.
What do you think are some of the cultural reasons that this cradle-to-cradle logic hasn't entered the mainstream as quickly as it should?
Cultural reasons. Well, I think general reasons. Yeah. I think part of it has to do, I think, with that the first industrial revolution happened in northern climates. And in northern climates, we have a tendency to bury things because they don't rot. I mean, if you leave a banana peel out in Iceland, it's going to be there for a century, you know. Things don't disappear. And so we have a tendency to bury things, including, you know, our emotions and things like that. But I think the idea that we would see things like waste as negative things to be put away out of sight is really a cultural, an ingrained cultural phenomenon in the Northern Hemisphere. Whereas if you go to the South, or you go to India, where the whole idea of reincarnation it just seems natural to everybody. When we do our work in India or China, people just go, oh, sure, of course, you know, of course it's like that. You know, things go in cycles. Whereas in the Northern Hemisphere, you know, it's like, no, it's cradle to grave. You know, we developed the whole strategy for a reason. You know, it's culturally embedded. So I think part of it has to do with that. I'm being serious. I think it really does. I think, you know, cradle to cradle is in counterpoint to cradle to grave, and cradle to grave is the industrial paradigm of the first industrial revolution.
Has cradle to cradle been as popular in developing countries with less strict building regulations and less money to spend on alternative building? If not, how does your company plan to make your ideas more accessible to these developing countries, excluding China?
Well, I think for us, we're just right now it's the two of us, so we're trying to cover as much territory as we can. The plan right now is to take our protocol and give it to hundreds of organizations that want to use our database as we release it to the public, basically, and use it to assess products around the world, so that there would be assessors everywhere who are using the same sets of tools. And then they could bring it to the center for certification, things like that. So we've set up operations in some other countries already, but we just obviously have a really long way to go. It's our next big push. The Dutch have taken up cradle to cradle as a nation with great vigor. The Danes are looking at it now as something that they're very excited about. So sort of one country after another, we're trying to put our time in and help them think about it, but it's clear that we'll have to do something dramatic to allow it to manifest itself on a global basis. It can't just be two people, you know, working away.
What are your thoughts on greenwashing in terms of marketing by larger corporations that's becoming more prevalent as environmentalism becomes more popular? And do you think that this in any way makes people more skeptical of the kind of work that people like you are doing?
I think the concerns for greenwashing are really important to think about. The biggest problem, I think, with greenwashing is the use of the term green, because it's so undefined. And so I think that there's so many people working without being in a defined system. For someone like me, when I look at eco-claims on products, it's all greenwashing most of the time, because the people are working in an undefined system. The reason that it doesn't, the reason I don't get worried about us doing greenwashing per se is because we're trying to define a system. That's what we're trying to do. And so all we can do is say, within the system that we're trying to work with, you know, this is what we've found from the science. And so I think the biggest issue with greenwashing is that it relates to undefined systems, and that's where it gets into trouble. So if somebody says we're the, you know, get our new natural cleaner, and then you find out that it's from Clorox, you know, and that begs one set of questions, right? Like, what about all the other products that are being made, for example? That's a question. And then what does it mean to be all natural? Well, all natural doesn't necessarily mean good. Some of the most severe carcinogens we know are natural. So that's another undefined system. You know, it's all natural, but it could be all natural toxins. You know, I mean, and then the other thing we find is that the funniest one, I think, the one that makes us chuckle, but it's uncynically, it's truly humorous, is the one where they sell things that are like chlorine-free. I always love that. We were asked by a company to design a package that was chlorine-free, and we said, well, we can do that, but you're designing something that you want to sell what you're not. That's really interesting. I mean, we told them, why don't you just put plutonium-free right on the package, and it doesn't cost you anything, and you got a great new claim that we'd never heard before. So the idea of people selling what they're not, I find that really amazing as a green claim. But it is a really important thing to watch out for greenwashing. But I think, in the end, I think the people are really, most of the people are earnestly trying their best to do something meaningful. If you talk to the people in these companies, they believe what they're doing is better than what they were doing before, and they're trying to do a good job, and they just may not know what they're doing. Per se, you know, sometimes. So, but I don't know that it's not well-meaning. I just think it's undefined, and we need some science.
I understand what some of the economic benefits. I understand what some of the economic benefits are of Cradle to Cradle. So, can you expand on how you're creating these economic benefits? How were you able to save Ford so much money?
Well, that's a great question. In the case of Ford, what had happened is that we were brought in after the engineering had already been done on the stormwater for that site. So we had the benchmark to use as a reference point, and that was a $48 million for 3 chemical treatment plants, a whole bunch of 4-foot concrete pipes, and the need for a whole bunch of UAW workers standing around at $70 an hour praying it doesn't rain. Right? That was the stormwater management system. And you got to understand that with stormwater, what you're dealing with is the deluge. You're dealing with, you know, some 2-inch event, and it wants to leave the site in a matter of minutes. And so what we realized is that if we use the green roof and porous paving, all the parking lots, we took all the fines out of the gravel so that the gravel's all one size. And so water just goes right through the asphalt, just whoosh, into the gravel beds below the parking lots. So everything became porous and water absorptive. And by just doing that, we ended up building that for $13 million. So we had the previous scheme, which was already priced at $48 million, and already on Ford's books to be spent, because it was to meet the Clean Water Act. And by law, Ford was required to meet the Clean Water Act. So they were going to spend $48 million. It was already on the books to be spent. So that's how we were able to save them the money. In other cases, like the fabric in Switzerland, when we went from all these 250 some odd chemicals they were using down to the 38, it cut back on all their regulatory costs because they didn't have to fill out paperwork. So it saved on regulatory costs. And once the water coming out of the mill was as clean as the water going in, they didn't have to meet with inspectors every week to inspect the water coming out of the factory. And these kinds of things, they didn't have hazardous material storage. One of the ironic ones that happened is they got complaints from some of the workers because they weren't getting hazardous duty pay for working with carcinogens anymore. That was a bit weird. So they got complaints. Amazing. But they saved money from that. So it reduced the cost of making the textile about 20%. And that's really important because if we're going to have local industries, what happens with Cradle to Cradle is that it trends toward local manufacturing. I don't know if you can see that, what happens with it, but it's quite astonishing. When the materials go into closed cycles, the real value proposition of the materials is actually in the relationship to your customer, and the costs are primarily around reverse logistics. So the tendency of Cradle to Cradle, if we go for another 4 or 5 generations out, would be for the products to say come from China in this generation. But if the materials get here, they're of so low value in their next life, going toward their next life, that the real issue becomes relationship with customer. And then those materials end up stored on Long Beach getting ready to be shipped to somewhere, but there's nowhere for them to go because China is no longer taking back the plastics from the United States. I don't know if you know that. The stuff's piling up. And what's interesting is it's going to want to be used here to go into remanufacturing. So it'll actually come back into the cycles here. That's why it's so important that they use Cradle to Cradle materials as they send them to us so that we have safe, healthy things that we can recycle. And then we make safe, healthy things that we can distribute internally as well as export for our benefit. So those equations have to be ones like the one in the textile where we actually save money, because there are very few textile industries left, certainly in the United States and certainly in Switzerland. I mean, you can imagine making textiles cost effectively in Switzerland compared to China, and yet they are doing it, right? It's really critical that we adopt these protocols for us to be able to afford to have local industry. Thank you very much.